So first of all, welcome. It's good to see people here. It's good to be here. So I hadn't been in Beijing before, so it was an excuse or an opportunity to come. So I wanted to talk first just a little bit about what we want to try and cover today, a little bit about the purpose of the event, and maybe just a little bit on expectations. So we first did this event last year. We did a DPDK and FD.io mini summit when this event was in Berlin, and it was very successful. So we decided to repeat it again this year. The reason for doing it is there's a very strong historical link between DPDK and NFE. So I talked a little at the lightning round yesterday about some of the linkage between DPDK and NFE. If you look back to the original ETSI NFE white paper back in 2012, and if you look at the challenges for NFE that it spelled out, DPDK helps to address a number of those. So in that white paper back in 2012, the network operators who put it together talked about the challenge of high performance. So performance is very broad in nature. It encompasses lots of things, but one of the main things that you need is high performance for network I/O. So if you can't get data into and out of your system fast enough, then nothing else matters. Your performance is never going to be good enough. And that's the whole reason for being for DPDK. It's the most efficient way to get data in and out of the system. So that's one of the challenges. A second challenge that was called out in that white paper was portability of applications. So being able to run VNFs on multiple hardware architectures. So DPDK started out as an Intel technology a number of years ago, but it's transformed over the last number of years into an open source, a multi-vendor open source project. So it's fully open sourced under the Linux Foundation now, multi-vendor, multi-architecture, supports all the main CPU architectures, supports all the main NIC vendors. So we help in terms of that portability requirement as well. And a third challenge that was called out in that white paper was reliability of hardware and software. There's a lot of work being done in OPNFE, particularly in projects like Doctor and Barometer, on service assurance. So making sure that you have the right sets of statistics available for ensuring the right level of service, for calculating the right KPIs. And we've done a lot of work in DPDK over the last number of releases to support those service assurance activities. So we just have the bottom layer of the stack, if you like. So the DPDK piece is exposing the right statistics so that they can be consumed by high-level applications. So that's the DPDK linkage. FD.io is a little bit newer in terms of an open source project. It hasn't been around as long, although it's been used internally within Cisco for a long time before that. And there is a specific fast data stacks project, which is looking at integration of FD.io into OPNFE as an alternative NFVI. There's obviously a strong linkage between DPDK and FD.io. So that was the reason for doing a joint event rather than two completely separate ones. Just in terms of expectations for the day, so these kind of events are usually more productive if they're a bit more interactive. So if you have questions, feel free to ask. All of our speakers should hopefully have a little bit of time at the end for questions and answers. So if you do have questions, feel free to ask. The other thing I would say is that feel free to track the speakers down afterwards if you want to discuss any of the items in more detail. People will be around. Find the right person, arrange an offline conversation. You'll get more out of it that way. Right. Okay, that's good. So just in terms of the agenda for the day. So the morning is focused more on DPDK. I'm going to do a quick intro, talk a little bit about the transition of the project to the Linux Foundation, a little bit about the roadmap. Then Steve is going to talk about data plane virtualization enhancements. So again, there's been a strong focus over the last number of DPDK releases on improving data plane performance, data plane virtualization performance. He's going to talk a little bit about what's been done and what's going to be done in future. We have a couple of guys from Red Hat then, Frank and Christian, who are going to talk about putting OVS DPDK into production, specifically with zero packet loss. So that's the DPDK-enabled version of Open vSwitch. We'll take a break for a while, and then a couple of guys from Huawei are going to talk about a cloud monitoring framework that's built on DPDK. And the last talk we have in the morning session is Jianfeng is going to talk about FD.io user as what we call an exception path in DPDK. So it's a way to transfer data between DPDK and the kernel. We've had an alternative implementation we call KNI for a long time now. FD.io user is an alternative way of doing that, maybe a cleaner way of doing that. And we'll take a break for lunch then. So that's the morning session focused mostly on DPDK. The afternoon kicks off about 1:30. Balaji is going to do an FD.io overview, maybe a little bit on the roadmap. I'm not sure, to be honest, exactly what he's going to cover, but we'll see when the time comes. Ray is going to talk about containers, so support for data plane, I guess DPDK, FIDO, whatever else in containers. That's one of the reasons for making this a combined event. There are a couple of talks which kind of span FIDO and DPDK. Ray's is one of those. We have a couple of people from ZTE then who are going to talk about implementing a virtual network service on VPP. And then we'll take an afternoon break. Danny and Hongjun, I'm not sure if it's the two of them or just one, but they're going to talk about enabling high-performance, flexible 5G user data plane, and specifically service function chaining in VPP. There's been a lot of work done in the NSH SFC project in FD.io to enable service function chaining. So it's been a big area of focus. And then Anna is going to talk about DPDK and CSIT. So CSIT is the test automation framework, the test automation project within FD.io. There's been a lot of work done, obviously, to enable VPP testing, but recently there's been more focus on adding testing for some of the other FD.io projects. Anna has been involved in contributing test cases for TLDK, for example, and also some DPDK tests in there. So Anna's going to talk about that engagement in the CSIT project and trying to make it a more complete test suite, I guess, rather than the initial focus more just on VPP. And the last item, and again, it's one that ties together DPDK and FD.io, is Fan is going to talk about crypto and IPsec. So that's taking the CryptoDev API that's been developed in DPDK, integrating it into VPP IPsec, and significantly improving the performance of VPP IPsec as a result. So it's a good combination of DPDK and FD.io and showing how if you put the two together, you can achieve a high-performance data plane solution, in this case focused on IPsec. So that's the agenda for the day. Just a little bit about the open source project for DPDK right now. So we had a big change back at the start of April. It was announced at the Open Networking Summit that DPDK was moving to the Linux Foundation. It's been an open source project for many, many years now. The hosting of it was previously done by Sixwind, and the perception in the community was that the project had outgrown that hosting model, that we needed a more formal governance structure, we needed a more formal hosting model. So that resulted in a series of discussions over the last number of months about transitioning the project to the Linux Foundation. And that move was announced like I said, the start of April at the Open Networking Summit. So we have a set of project members now who are very representative of the kind of industry interest in and usage of DPDK. You can see there are a set of hardware, but I guess I should explain. So the top 8 logos are the gold members, or the top membership level for the project. There is actually a 9th one, but that 9th one is still going through the approval process to be able to use their name publicly. So I can't mention who it is, but there are actually 9. The bottom 5 then are the silver members, so that's the lower membership tier. There's also an associate membership tier for academic institutions, nonprofit organizations. So there are 4 of those, I think. But the interesting thing is if you look at the spread, there are silicon vendors there, there are software vendors, there are service providers, there are telecom equipment manufacturers. It's very representative of the reach of the DPDK project. The governance model hasn't changed significantly, but I guess it's been more structured and made a little bit more formal. So we have 2 entities really that govern the project now. There is a governing board, which is up and running now. Trishan runs the regular meetings of that. And that deals with all the typical issues that a governing board on an open source project usually deals with. So it's dealing with budget, marketing, any administrative and legal issues, managing lab resources for the project, things like that. And the board is composed of representatives from all of the gold members. There's also a representative on the board representing all of the silver members, who happens to be a rep from Huawei. We also have a technical board that was actually in existence before we started talking about this transition, but what's changed now is it's a lot more active. So they have regular meetings. They used to meet on an exception basis, only if there was a particular issue to talk about. The recent change is that they meet on a regular basis. The meetings are public. The agenda is notified in advance. Anybody can join. And the technical board is really setting the technical direction for the project. So the classic example of where something gets referred to a technical board is if there's some debate on a set of patches, that there's difference of opinion on whether they should be accepted or not. So we set this up specifically as being the decision-making body when there's any doubt over whether a set of patches should be accepted or not. They're also a little bit more forward-looking, so looking at changes that will need to happen and the impacts of that, and considering the best way to implement. So those are really the 2 boards that collaborate now in terms of the governance structure for DPDK. Beyond that, nothing has really changed. So the project remains at dpdk.org exactly as it did before. The release cadence is the same. The mechanics of submitting, reviewing, accepting patches are exactly the same. That's all based on Linux kernel, and we have a strong set of maintainers now who review and disposition the patches that are submitted. So one area we have been looking at with this transition, looking at trying to improve, is the level of performance testing in DPDK. So this is just showing what we have right now. What happens right now is we go through a release cycle, we apply a series of patches, we build a release, we do some performance testing at the end, and then different vendors, predominantly Intel, but also Mellanox, publish performance results, which are posted on the dpdk.org site. So these performance reports are like the definitive statement on DPDK performance for the release. They're the official statement of performance. There are performance reports available for 17.05 now. They're not actually posted on the dpdk.org site yet. We need to do a quick web patch just to update that. That should be done in the next day or 2. So within the next day or 2, you'll be able to look on the documentation page under dpdk.org and see the history of performance results, performance reports from 16.11 to 17.02 to 17.05. So that model is very much testing at the end of a release. One thing we've been trying to improve is how do we determine if there's a performance impact before you get to that point. So if you apply a set of patches, you build a release, you do performance testing, and then you find there's a problem. It's 2 problems with that. First of all, you have to go through an exercise to try and narrow down which patch or set of patches actually caused that issue, which isn't always immediately obvious. And the second thing is that you're right at the end of the release, a week or 2 maybe before you plan to make the release. So it's not the ideal time to be trying to address any fundamental performance issue. So we've had lots of discussion in the community about can we find those performance issues faster? So can we, when patches are submitted, automatically test the performance of them and determine whether there's a performance regression caused by that set of patches or not. And this would then be an extra input to the maintainer. And the maintainer would, for the relevant area, would still make the final decision on whether to accept that patch set or not, because sometimes you do have to accept changes that have a detrimental impact on performance, but you should do that forearmed with the knowledge of exactly what that performance impact is. In other cases, the performance impacts are unexpected, so being able to identify that as soon as the patches are submitted would be very useful, giving the author of the patch set time to do the necessary rework and optimize performance. So that's the goal, that's what we want to set up. We've had some discussions on how to do it. At the last governing board meeting, they approved the concept and the budget for it. We've decided to host a DPDK lab, kind of similar in concept to the CSIT lab within FD.io, for those of you who are familiar with it. That will be hosted at the Interoperability Lab in the University of New Hampshire. So the University of New Hampshire do a lot of interop and certification testing for networking software. They do a lot of work for the Open Fabrics Alliance. They do a lot of Ethernet certification and compliance testing. So it's a good home for a networking software lab. We have a lot of work to do with them probably over the next 6 months to get it established, set up and running. But the aim is that we don't have a definite time frame, but maybe around the end of the year, sometime around then, we'll have an automated way to automatically performance test the impact of patches as soon as they're submitted, so that we can make an informed decision on whether that patch or patch set should be added to the main repository or not. So just in terms of roadmap, this is just showing the release cadence. So we had 3 releases through 2016. The one interesting point is our last release in 2016, 16.11, was an LTS release. We had never done LTS releases before, but there were a number of requests for it, some from the OS distros and from some customers as well. So the plan for that LTS release, 16.11, is that we would maintain it for 2 years. We would backport fixes to it for 2 years. So if you base an application on a 16.11 release, you know that you'll still be able to remain on that release and still avail of the latest fixes for a 2-year period. So it's really trying to provide a little bit more long-term stability. If you want the latest and greatest features, then you need to move to the latest release. So it's really a trade-off. If you value stability, you might want to look at the LTS releases. If you want the latest and greatest functionality and features, then you obviously need to go with the latest release, so it's an option. We are having some discussion about whether that's the right, the original plan was that we would do the .11 release in every even numbered year. So 16.11 and then 18.11 and 20.11 would be our LTS releases. There's some discussion now as to whether we change that. Maybe we make the last release in every year an LTS release. So maybe 17.11 will end up being an LTS release. The plan at the moment is 16.11 and then 18.11, but that may be subject to change. The other thing to note, I suppose, is that through 2017, we moved to a model where we were doing quarterly releases. So we have 4 major releases this year. Just finished 17.05, just coming towards the end of the development cycle for 17.08. And then we'll have a 17.11 at the end of the year. So looking back at 17.05, this is our standard picture of the DPDK framework. It seems to get bigger and busier every release. It's really showing the libraries and the drivers that reside within DPDK. Looking at some of the changes for the 17.05 release, the first thing we had was we had a number of new drivers. So the ARC PMD is for atomic rules, FPGA-based devices. AVP is Wind River's Accelerated Virtual Port, I think is the acronym. I could get that wrong, but I think that's what it is. Liquid I/O is from Cavium, DPAA2 is from NXP. So typically we see a steady increase in the number of devices supported by DPDK across every release. That happened in 17.05, just the same way as it has with all the recent ones. There was a lot of, we've focused a lot, I guess, on crypto performance and crypto implementation over the last number of releases. And Fan is going to talk at the end of the day, I think is the very last talk of the day, if I remember correctly, about the DPDK crypto dev implementation and the way that's consumed now in VPP to accelerate IPsec. So crypto dev is a look-aside crypto acceleration model for symmetric crypto. So it's really targeted at the algorithms that you need to do IPsec data plane. It supports both hardware and software acceleration under the same API. So you can use hardware acceleration via Intel's Quick Assist, and actually just in 1705, NXP's DPAA2 as well. There are also a number of software accelerated drivers underneath the CryptoDev API. It started out with the Intel's AES-NI multi-buffer library. We have a number of libraries now for different wireless algorithms, Snow3G, Zook, and Kasumi. There's also been a focus over the last couple of releases on the scheduler. So the scheduler is trying to allow you to make more intelligent use of crypto resources. So more intelligently mix hardware and software crypto. So for example, if you are dealing with small packet sizes, you might not want the offload cost for offloading to a hardware accelerator. It might be quicker and easier to encrypt or decrypt in software. So the scheduler allows you to make decisions like that. The next thing that's new in 1705 is the Event Dev API. So historically, DPDK has operated on a polling model where the poll mode drivers are constantly polling the Ethernet devices looking for packets. The Event API operates in a different way. So it's, as the name implies, it's an event-driven approach. So instead of polling for packets, a core will make a call to a scheduler process, and the scheduler will determine what traffic to allocate to that particular worker core. So there are a couple of implementations. There's a software implementation. The skeleton is really just for test purposes, and there is also an implementation for Octane TX as well. So it's an option. If you want to use an event-driven model, there is the capability to do that. But the predominant focus of DPDK is still on polling mode. And the last area to highlight is just in terms of metrics. So I mentioned at the very start that one of the areas where there's been a strong engagement between DPDK and OPNFE is in terms of satisfying some of the service assurance requirements coming from the barometer and the doctor projects. We've done a lot of work over our last number of releases in exposing better statistics and making the collection of those easier. What we added in 1705 is a metrics library, which allows you to add more sophisticated statistics capabilities. In 1705, we added latency data. So max, min, latency, jitter, things like that, and bitrate, peak average bitrate. So it just allows an easy way to collect that kind of data from an application and report it to some kind of monitoring collection process. So that's 1705 and what was new in 1705. Looking forward then to 1708, which is due sometime in August. This is just, for the first slide now, is just the main items on the Intel roadmap, the things that we're contributing. So one of the big focus areas over the last number of releases has been trying to make the DPDK APIs more generic. So we have always had generic APIs, but there have been lots of device-specific APIs as well. So there was a lot of work done over the last couple of releases in implementing an RT flow API to do filtering in a consistent way across all Ethernet devices. The focus in 1708 is on looking at quality of service. So we've had a software quality of service implementation in DPDK for a couple of years now. I can't remember exactly when it was done, but a couple of years back. There are also QoS capabilities supported by various Ethernet devices. So what we're doing in 1708 is a generic QoS scheduling API that will support then the Fortville and Niantic Ethernet controllers, and also will work on top of the existing DPDK software quality of service implementation. So that's just continuing the trend towards more consistent and more generic APIs. The third item there, the RTE flow enhancements, is just the continued evolution of that RTE flow API. I think it was done originally back in 1702, that kind of time frame. So there are some enhancements going in for the IGB and IXGB devices in 1708. Relating again to service assurance, so one of the requirements that we've been looking at is to implement IPFix, the flow information export. So that's exporting flow-based information and flow-based data. We have an RFC that's been posted on the developers mailing list, and there's been some discussion about the right way to implement that. So it's unlikely to be implemented in 1708. The implementation of it is much more likely to be 1711. But there's been a good discussion on how that should be implemented within DPDK, what the pros and cons of it are. So it looks like we should be on a path to do that in the 1711 timeframe now. GRO, the generic receive offload, is a software implementation that we're doing in 1708. So it just supports reassembly, or uses the reassembly library that exists in DPDK already. And the CryptoDev, the multi-core software scheduler, is another enhancement to that crypto scheduler that I talked about. So previously it supports the ability to mix hardware and software acceleration. So based on algorithm and packet size, you can decide whether to offload to hardware or not. The multi-core aspect is just adding better scalability for software crypto. So you can more efficiently use a number of cores allocated to do software crypto, use them in a more flexible way. But again, it's a next step in terms of trying to build out a more flexible implementation that allows you to make optimum use of the crypto capabilities that exist in DPDK. So that's 1708. Looking a little bit further ahead, well, actually, there's one more thing on 1708. So this is just a snapshot. There is on the dpdk.org website a public roadmap posted there, and this is a snapshot of what it shows for 1708. So that includes input from Intel, which is my particular area of interest, but from other vendors as well. There are a couple of things that are out of date on that, and maybe they should be updated, and it's only when I was putting this slide together last night that I noticed that it was out of date. So I crossed out a couple of items. The Zen NetFront driver was an activity that Brocade were planning to do for the 1708 timeframe. It didn't get submitted. They might reconsider and do that for 1711 later in the year. I'm not sure, to be honest, exactly what their plans are there, but it didn't make the cutoff point for 1708, so it won't be there. The other one that's crossed out, the VF restore after PF reset, was trying to find a way to do more automated processing of within the VF when a PF reset occurs. Some discussion on the right way to do that and what is and isn't feasible. So that needs a little bit more investigation, so that won't be in 1708 either. One specific non-Intel item that is worth calling out is the fail-safe driver. So we've supported hot plug capabilities, some hot plug capabilities in DPDK for a number of releases now, but it does rely on the application attaching or detaching the relevant device. So it's not a full hardware hot plug capability. The fail-safe driver is work that's being done by Sixwind, which will provide that capability. So it basically allows you to configure a primary and a number of secondary devices and builds in a hot plug capability then if traffic needs to switch from the primary to one of the secondaries. So we transmit, I think, always on the primary device. We receive on all of the devices in that set. But what's interesting about that is the hardware hot plug capabilities that are built in as part of it. So that's 1708. Looking beyond that, so the question that we always get asked is, well, what's your roadmap beyond that? The question I always ask in return is, well, you know, what do you want to see there? So what I didn't do was draw a roadmap as such. The next slide or two are just a couple of bullet points on things that we're considering for subsequent releases at the end of this year and early part of next year. But it would be very interesting over the course of the next couple of days to get people's feedback on what you would like to see there, what your priorities are, what your particular areas of interest are. Because the more input we get on your priorities and areas of interest, the easier it is to develop a roadmap that suits. So just some of the things that we're looking at. There's going to be continued work on the CryptoDev API. Specifically, there's some discussion on adding capabilities for asymmetric crypto. So a potential use case for that might be to accelerate SSL TLS, something like that. So I think that will happen maybe in the 1711 timeframe, maybe 1802, something around those two releases. There's also discussion, for those of you who follow the development mailing list, you may have seen on inline crypto capabilities. So we've been looking at enabling inline crypto on some existing devices, and there's some interesting discussion amongst the different vendors on the way to do that and trying to find a generic solution that suits every vendor's models. We always had the concept when we added the CryptoDev API that was the first accelerator type that we would add to DPDK, and we would add other accelerator types in future. And there's continual discussion on what other accelerator types we might add in future. The obvious one that we've talked about since the beginning is compression. We don't have a hard and fast plan for that yet, but that's something we may look at some point over the next number of releases. Again, those of you who follow the development mailing list will have seen some discussion on support for programmable devices. So there was a proposal to add a ProgDev, programmable device API to DPDK as one way to be able to configure, download a personality to a programmable device. That spawned a lot of good discussion on, is that the right way to do it, or is there an alternative way to do it? There's some investigation in progress on into different models for support of programmable devices. So over the next couple of releases, I think you'll see more in terms of DPDK support for programmable devices. Performance enhancements for virtualization and containers are a recurring theme over the last number of releases and will be for the foreseeable future. So Steve, in the next session, is going to talk about that in a lot more detail. Another theme that we've had for a while is finding better ways to interwork with the kernel. So we've had KNI for many years now. Jianfeng is going to talk about use of virt.io user as an alternative exception path. But there are continuing discussions about, are there better ways we can interact with the kernel? Can we somehow take advantage of capabilities being added to the kernel like XDP? Is there some integration between XDP and DPDK? We need to be looking at things like that. And the last trend, like I mentioned before, is just to more generic APIs. We've done the Flow API now. The QoS is in progress. And we need to do more in terms of making sure that APIs are as consistent as possible across device types. So just one slide in terms of DPDK consumption. So this is just looking at, well, I guess the box in the middle, the DPDK and OS distros is listing out places where DPDK is packaged. And that's grown steadily over the last couple of years. I think we started with Fedora a couple of years ago, and then FreeBSD, and it's kind of steamrolled from there. But DPDK gets packaged in all the main OS distros now, so it's just an alternative distribution mechanism. The rest of the slide is talking about some of the other open source projects that build on top of DPDK. So I mentioned FD.io and VPP specifically, and that's what the focus of the afternoon session is. Frank and Christian later are going to talk about the DPDK-enabled Open vSwitch. And there are a number of other vSwitches which support acceleration via DPDK. a number of packet generators, and an increasing number of DPDK accelerated TCP stacks. So we see a growth in consumption ecosystem built around DPDK. So this is just some links to further info. So the main reference point is always the open source website at dpdk.org, and you can get to pretty much everything from there. Like I said, there's no change in that as a result of the transition to the Linux Foundation. That remains the focal point for the DPDK project, and the day-to-day operations around that haven't changed at all. And one last thing I wanted to mention. So we do this event co-located with the OP NFE Summit, but also for the last number of years, we've done a dedicated DPDK Summit in China. It just happens this year from a timing point of view that the two are fairly close in time. Maybe that wasn't the ideal planning, but that's the way it worked out anyway. So we have a one-day DPDK Summit in Shanghai on June 27th. So that'll be more detail, more depth, more of a deep dive type session, and a chance to meet more and interact with more of the DPDK developers. We have a large development and validation team based in Shanghai. So if people are interested in attending that, it's a chance to meet more of the developers and the validation engineers in person and have some offline discussions there. And that's it. Are there any questions before I hand over to Steve? No? Okay, so next up is Steve, who's going to talk about virtualization performance improvements in DPDK over the last couple of years and some upcoming activities over the next couple of releases. Thank you.